We are going to start with increasing, decreasing order. Right. The order is very important, and if it is given key, we have to specify the order. So how we have to deal with the question, like the first case when I'm saying like there are 10 students, including A and B. We have to make a rank list of these 10 students such that A will be always ahead of B. A will be always ahead of B. Right? First way how we can solve this is A will be ahead of B. The numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of these 10, we are selecting, out of these 10 positions, we are selecting 2 positions, right? Let's suppose when we are selecting 2 positions, 1 position this, and second position, we are selecting 2 and 8, right? 2 is for A and right, and 8 is for B, right? We can arrange A and B in only one ways, right? And all the other other 8 students can arrange themselves in factorial 8 ways. So first we have to we have to give the specific order to A and B. So for that, what we have to do, just fix 2 positions for them, and rest 8 position they can arrange by themselves. So we are going with 10C2 into factorial 8. This is the first method to understand this. Second method, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A and B are 2 students other than like C, D, or C1, C2, C3 up to C8. 80 students are there, right? We have to arrange these 10 students in such a way the position of A and B will be specific. A will be ahead of B. So what we are thinking, okay, let's see if we are not giving any order to these 2 persons, means we are saying that both are identical alpha and alpha, and other C1, C2 up to C8 are there, right? So if these 10 people has to arrange in these 10 position, this will be factorial 10 by factorial 2. The factorial 2 is for both alpha and alpha are identical. If both alphas are identical, so let one alpha is coming there and a second is going there, then I can say, okay, we have not given any order to these 2 alphas, but one alpha is A and other alpha is B. So now we have to give the name, the above one, I'm giving the name A, and below one, I'm giving the name B. So first we have to restrict the order or the shuffling of them, and then we have to go for this A and B, right? This is the second method, right? Third method. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In all 10, we have to write down A, B, and 8 others. we have to arrange in such a way A will be always ahead of B. So total number of our arrangement will be factorial 10. Total number of arrangement will be factorial 10. In half of the position, A will be ahead. In half of the position, B will be ahead. So if I'm taking half of the cases, means A will be always ahead of B, right? So again, we are going for all three, right? First method, 10 students, including A and B, we have to make a rank list of these 10 students in such a way A will be always ahead of B, right? So A will be always ahead of B. If we have to, anyhow, you have to give the rank of any 2 student, 3 student, 5 student, or like. So first method is we are selecting 2 position out of 10, right? So we can select those 2 position out of 10 will be 10C2, right? 10C2. And other eight students are arranging themselves in factorial 8 ways. So 10C2 into factorial 8, right? Second method, we are saying that in this case, we are restricting the order or the shuffling of A and B, right? A and B can shuffle by factorial 2 ways. So I'm assuming both A and B are alpha, and other 8 students are there. The number of arrangement of these 10 people will be factorial 10 by factorial 2. And now we are multiplying with 1. 1 is showing this key, like the above one alpha I'm writing A, the below one alpha I'm writing B. We are giving the specific name A and B, right? Because that's the only one way we can do, right? And the third way is like simple one. For 2 people, it will be very simple. We know that, but more than 2, it will not work, right? For more than 2 people, we have to see how it's going, right? Now, there are 10 speakers in which A, B, C decided to deliver a speech as first, A will be ahead of B will be ahead of C. Second, A will be ahead of B or C. Third, okay. There are 10 students in which A, B, C are there, right? They decided to deliver the speech as A will be ahead of B will be ahead of C, first question. Second, A will be ahead of B or C. Third question, A will be ahead of B will be ahead of C. And all the 3 speakers in coming in first 5 position, right? First 5 position only they have to deliver. Right? In how many ways we can go for this, right? Think like you can take 2 minutes for this, maximum 4 minutes for all the questions, right? Go ahead. So with the first, I can say like the direct question is there, right? The first way for this is 10C3 into factorial 7, or we can say factorial 10 by factorial 3 ways, right? For first, we are getting answer, both are same, right? In both the things. For first case, what I'm doing, I'm selecting 3 position out of 10, right? And specify for A, B, and C, right? The topmost for A, then second is for B, and third is for C. And the other 7 position can sit in factorial 7 ways, right? The second on this, we are solving this by factorial 10 ways is total number of ways how they can sit, right? And but the order of A, B, and C, we have to diminish, and the order of A, B, and C, they are taking the order as factorial 3 ways. So dividing this by factorial 3. Same question is there in the second case, but the order in this will be 10C3, right? 10C3, and in this case 10C3, we know that factorial 7, the other 7 people are sitting, but for A, B, and C, we know that they can sit by A, B, C or A, C, B, right? Two cases are there, right? First or second, I can say factorial 10 by factorial 3 into factorial 2, right? Or factorial 10 by 3, both way. And the most important, this A, B, C. 3 numbers, right? First 5 position, 1, 2, 3, 4, 5. So I'm selecting 3 position in first 5 by 5C 3 ways, and they will arrange in only one way. Now we have again 6, 7, 8, 9, 10. So all 7 positions, they can go by factorial 7 ways. Hope you all are getting this, right? And getting right answer on this. But in this specific order, right, there are 50 white balls and 50 red balls numbered 1 to 50, right? And you have to apply the same concept in this, right? Like we have in third case, you can see we have a specific the order. In first 5 position only we required A, B, and C, right? So first 5 position only. So from first 5 position, we are selecting 3 position, right? First 5 position, I'm selecting 3 position, and this is 5C 3 ways, right? If 5C 3 ways giving 1 position to A, other to B, third to C, right? And other 7 position, now they are arranging in factorial 7 ways, right? So a specification must be there. So same thing I'm doing here. There are 50 white ball numbered and 50 red ball numbered 1 to 50, right? We have to arrange 100 balls in a row such that first white balls are in increasing order. Second, white and red balls are in increasing order. Third, white balls are in increasing order and red balls are in decreasing order. Fourth, white and red balls are alternatively, right? Arranging alternatively. Only 4 questions and beautiful questions are there, right? So maximum you can take 4 minutes for this, right? Please. if you are able to understand the last concept now, that this is a like either way you can go. By first method, selecting the position, then arranging this, or the second method, we are diminishing the arrangement, right, and then giving the arrangement, right. Try this. Very good, very good. Last one net thing on this, then I'll go ahead. start with first one. White balls are in increasing order, right? There are 100 positions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 100, right? So in these 100 positions, we have to select, right, 50. So if I'm selecting 50 position, in these 50 positions, if we have to put, these 50 positions are there, we have to put 50 balls numbered 1 to 50. So 100% we have to start with 1 is there, 2 is there, 3 is there, and last will be 50. So specific order is 1 only, but the order we are giving to white ball, that must be increasing, but red balls are not taking any restriction. So in between the red balls can arrange there in factorial 50 ways. The first one, or the second, like this A I'm saying, the second way to think on this is we are arranging 100 balls by factorial 100, but we know that the restriction is on white ball. So the arrangement of white ball we have to diminish. The white ball arrange in factorial 50 ways. So if I'm dividing this by factorial 50 and arranging those white balls in one way, so we are getting the same answer. This is for white balls are in increasing order, either on this way, right? This way you can go, or this way you can go. You have both the way, right? So I'll request, I have applied this, the first, either you have to select and arrange, or we are not selecting, only arranging this, right? Like in second case, we are saying 100 factorial is the total number of ways, right? White and red both are arranging, right? But the white ball has not to arrange. So every white ball, I'm saying you all are alpha, right? So if white ball positioning we have to give. So I'm saying white ball, please don't arrange yourself. So how many ways you are arranging? The white ball said, okay, we all were arranging with factorial 50 ways. So I said, okay, diminish that, right? So I'm dividing this by factorial 50, right? But we know that this can be arranged in only one way, that's increasing. The lowest one will be 1, then it's 2, 3, 4, and the last one will be 50 only. Now, I guess you can apply this concept to second, third, and fourth. Again, I'm giving you 2 minutes for this. Apply this. So white and red balls are in increasing order, right? So 100 C 50, selecting 50 positions and giving to either white or red. And again, out of 50, selecting 50 first, or we can say factorial 100 is the total number of ways ball can arrange, right? But factorial 50, thus white and red balls are arranging that we have to diminish, right? The same answer for this, either this is increasing or decreasing order, right? The same answer is for third. Fourth, white and red balls are alternatively, right? So we know that this will be white, red, white, red, white, red, white, red. First and second, red, white, red, white, red, white. Right? The first is factorial 50 and second is factorial 50. Second is again factorial 50, factorial 50. So overall we are getting 2 into factorial 50 into factorial 50. Right? So increasing and decreasing order, right? Now, there are 3 students and their respective 3 students, S1, S2, and S3, and respective mothers are M1, M2, and M3, right? In PTM, management decide that they will interview the students first, then their respective mothers, right? Means if these 6 positions are there, 1, 2, 3, 4, 5, 6. First position, if student 1 is coming, then second position will be for either student 2 or 3 or mother M1, right? Like first position is for S1 and second we are giving for S2, then third position will be for any student can come, but M1 or M2 are coming, right? So M3 is not coming. Why? Because S3 has not come yet, right? So in how many ways we can arrange the interview, right? How many ways we can arrange the interview? 3 students, S1, S2, and S3, and their respective mothers are M1, M2, and M3. Management decide that they will interview the student first, then their respective mothers, not necessarily consecutive. In how many ways we can interview all the 6 persons? Then again, increasing, decreasing order, try to apply the concept on this question, right? Maximum 2 to 3 minutes you have. So look into this. The restriction is there for students and mothers, right? So if six positions are there, right? S1, S2, S3, M1, M2, M3. So restriction on these two, restriction on these two, and on these two, the restrictions are there, right? S1 has to come before S2. So what I'm saying, okay, let's suppose in factorial 6 ways we are arranging everyone, right? We are arranging everyone now. The restriction on S1 and M1, and they are interchanging each other by factorial 2 ways. So I'm dividing this by factorial 2. Again, S2 and M2, there is a restriction, so factorial 2 ways, and S3 and M3, that's factorial 2 ways. Factorial 6 by factorial 2, factorial 2, factorial 2, right? Or we can think in this way. In sixth position, we are selecting two position. Now, first position giving to S1 and second position giving to M1. Now, rest four position, again, we are selecting two, and first position giving to S2 and second position giving to M2, and the rest is to C2. In either way, you can go and solve this. Like in this question, mother, and also I'm including fathers, F1, F2, and F3. And management decide that they will interview the student first, then their respective mother, then their father. In how many ways we can arrange them? We have to find, like we have to interview the 9 person, like S1, S2, and S3, M1, M2, and M3, and F1, F2, and F3 with a specific order that SI will be ahead of MI, will be ahead of FI, right? This is the specific order that you have to find, right? So in how many ways we can, I will be either 1 or 2 or 3, anything will be there, right? In how many ways we can arrange. Hope everyone getting this. And you have 2 ways. Either you can think in this way or that way, right? With increasing decreasing order, we have to form a 4 digit number XYZU in such a way, first, X greater than Y greater than Z greater than U. Second, X less than Y less than Z less than U. Third, X greater than equal to Y. Fourth, X greater than Y U. Again, a specific order is there, right, with X, Y, Z, and U. Like in first question, we have to write down X, Y, Z, and U, 4-digit number, right? X will be greater than Y will be greater than Z. We know that the digits are 0, 1, 2, 3, up to 9, right? And we have to select only 4. Now we have not to arrange, only we have to select, right? In how many ways we can select? 10C4. If I'm selecting any 4, the greatest one will be go to X, then to Y, then to Z, then to U. So the arrangement will be 10C4, right? So try to solve second, third, and fourth for the same. But we have to be careful for second. If we are selecting 0, so 0 will go to x. And if I'll put x is equal to 0, this will be not 4-digit number. So anytime if you are selecting 0, so 100% you are not able to write down 4-digit number, that will be 3-digit number. So for second case, we have not to select 0, but for first case, we can select 0 because 0 is going to u, that's a unit place. So no problem with that, right? So x, y, z, u greater than z greater than y greater than x. So total number of ways will be 9c4. Right? But third case, we have to divide into two parts, x, y, z. Oh, this is u only. And x, y, z, and u only. For this is 10c3. For this is 10c4. You have to add both this. Again, for fourth, x greater than y greater than z greater than u, x greater than y equal to z greater than u, right? 10c4, 10c3, 10c3, 10c2. Please note down carefully. Right? So this is called the increasing decreasing order, right? When we have to specify the increasing decreasing order for anything, right? Now, the last question on this, hope everyone will be able to do that. X1, X2, X3, Y1, Y2, Y3, Z1, Z2, Z3. We have to arrange these 9 letters in a row in such a way any alpha I, right, alpha 1, alpha 2, alpha 3, alpha may be X, Y, or Z in this order. Alpha 1 always ahead of alpha 2, always ahead of alpha 3. Means any X1, X2, X3, X1 will be ahead of X2 will be ahead of X3. In Y1, Y2, Y3, Y1 will be ahead of Y2 will be ahead of Y3, and same with Z. So in how many ways we can arrange all the 9 X1, X2, X3 up to Z1, Z2, Z3. maximum 30 seconds you can think, then accordingly we can go for this. You can write down in chat. Let's start. First way, write down the answer is 9C3, 6C3, 3C3. Or second way, this is factorial 9 by factorial 3, factorial 3, factorial 3. Both way, you'll get the answer for this, right? Next. This is a very, very, very important topic. This is called inclusion, exclusion. Inclusion, exclusion. In this inclusion, exclusion, what you have to do, what is the meaning of inclusion, exclusion? This is the set theory method. You can say like, this is one set A, and like this is another set B. So if I have to write down each and everything between A to B, right? So there's a problem, right? If I'm writing this, so you can see like the in between position, this is coming out twice, right? For black one as well as the red one. But other than this, all the positions are coming once. So if I'm going for writing down the answer, we know that the basic set theory formula for that. And basic formula says that this will be number of element in A plus number of element in B minus number of element in A intersection B, because we are right counting this twice. If it will increase for 3 sets, 4 sets, 5 sets, then accordingly it has to go. We know that for 3 sets, right, A, B, C. Right, this is the position A and B is taking. The position A and C, and the position B and C, right? So when we have to write down the complete set of this, so answer will be, we can write in different form on different ways, right? NA plus NB plus NC minus N, A intersection B minus N, A intersection C minus N, B intersection C plus N, A intersection B intersection C. For 3, for 4, for 5, for N, like every time we have to go ahead for that, right? So this concept we have to use for our like questions, which would be something like this. How many integers between 1 to 100 inclusive both are divisible by neither 5 nor 3. So we have to find total number of numbers between 1 to 100 inclusive both, such that this is not divisible by 5 as well as 3, right? So first write down the formula. Right? First write down the formula for this, and then based on formula only, you have to think how to go for this question, right? Then I'm giving you the so in this case we can see like 1 to 100. Total number 100 are there, right? So divisible by 5, right? So divisible by 5 is 100 by 5, we are getting 20. First. Second, divisible by 3. 100 by 3, the integral part is coming as 33. But in this, both the cases are included when this is divisible by 5 as well as 3, right? The integral part of this is 6. So I'm saying that total is 100 minus subtracting divisible by 5 cases minus subtracting divisible by 3 cases. But when I'm subtracting the cases divisible by 5, this also include divisible by 3. When I'm subtracting the cases when this is divisible by 3, this also taking the case of divisible by 5. So we are coming this 2 times as this was given here, right? So we have to minus all those here. So minus minus will be plus, right? So I guess everyone is getting the right answer and the concepts also, right? When we have to go for that. Okay. Numbers from 1 to 1000 not divisible by 5 and 3. The same question, right? For 1000. Do it fast. Hope this is simple one and everyone is getting this. Very good, I guess. Only the calculation part you have to take care. Right, so total number 1000 minus 1000 by 5 minus 1000 by 3 plus 1000 by 15. Just the calculation part you have to go for, right? For any big number or something, we can go ahead, right? Next, AA, BB, CC, DD, EFG, right? Or just I'm giving AA, BB, CD, D, E, F, G, 6, 4, 10. We have to arrange 10 letters in such a way first no two A's are together. No two A's and these are together. No two A's, B's and C's are together. Only two A's and two B's are together, but not two C's. It's a beautiful arrangement of question. Maximum you have to take 2 to 3 minutes for this, right? Already we have seen this type of concept, so not more than that you have to take, right? Please. See, no two A's are together, right? First, AA, BB, CC, DE, FG, right? No two A's are together, right? So we know that other than that, the two A's are together is totally, if I'm saying two A's are together, so this is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Factorial 9 by factorial 2 means two A's are together. But if I'm taking all are different, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, factorial 10, right? By factorial 2, factorial 2, factorial 2 for, right, double A, double B, double C are there. So for double A, double B, double C, we are dividing this by factorial 2, factorial 2, factorial 2. And this factorial 2 factorial 2 below factorial 9 is 4, right? Exactly two A's are together. And B double C, two same repeated number is there, right? So first one. Second, no two A's and no two B's are together, right? No two A's and no two B's are together. See, AA, BB, CC, DE, F, G. So the total number of ways it can go, right, by factorial 10 by factorial 2, factorial 2, factorial 2. Two A's are together is factorial 9 by factorial 2, factorial 2. Two B's are together, factorial 9 by factorial 2, factorial 2. Two A's as well as two B's are together, right? So two A's, 1, 2, 3, 4, 5, 6, 7, 8, factorial 8 by factorial 2. So this you are getting the answer. Maybe you all are thinking we can go with gap method also, but that will be a mistake. We can't go with gap method in this case, right? Because like if I'm saying no two A's and C, C, D, E, F, G, no two A's, no two B's are together. So maybe you are thinking in that way, you have all these gaps are there and we can put A and B's there. But in this case, we'll forget this number, AB, AB, or BA, BA, right? Something like this, no two A's, no two B's are coming, and this can go in anyhow in one place. So gap method will not work for this, and then we have to use this inclusion exclusion principle. This is total number of A's, two A's are together, two B's are together, two A's as well as two B's are together. See, no two A's, B's and C's are together, right? So total is factorial 10 by factorial 2, factorial 2, factorial 2, minus 9 by factorial 2, factorial 2, minus 9 by factorial 2, factorial 2, minus 9 by factorial 2, factorial 2, plus 2A's, 2A's as well as 2B's as we have find there, right? So 2A's and 2B's are together. Right, only 2A's as well as 2B's are together, right? Again, two B's, two C's are together, two C's, two A's are together, minus, right? All A's and B's and C's are together, right? Alternatively, going for plus sign, minus sign, plus sign, minus sign. This is called the inclusion exclusion principle. Right? Inclusion exclusion principle. Like if I'm saying there are 5 different balls and 3 distinct or different bags are there, in such a way each bag contain one ball. How many ways we can distribute the balls, right? This is the first case, 5 different balls and 3 different bags we have to arrange, right? So in inclusion exclusion, what we have done in this case, we can see the total number, this universal set minus and A means 2 A's are together, and B means 2 B's are together, and C means 2 C's are together, plus and A intersection B means A as well as B's are together, A, C's are together, C and D's are together, minus all 3 are together. So this was your answer. Right? Hope everyone is getting this. Okay. Now, based on the last one only, you have to go for this question, but you have to be careful on this part. Take your time. See, this is a very interesting question. So I'm going with 2, 3 methods, right? First, 3 bags, A, B, C. 3 bags are there, right? We are writing A, B, and C. The first method, right? Without this inclusion exclusion, right? So in how many ways we can distribute the balls? 3, 4, 5, 2, 2, 1. Only 2 ways are there, right? So 3, 1, 1, 2, 2, 1, right? For first one, A, I can say, right, we have to make a group of 3, 1, 1. So 3, 1, 1 group is factorial 3 by factorial 1, and two groups are same, so we have to divide this by factorial 3. And again, for the second one, the groups are factorial 5 by factorial 2, factorial 2, factorial 1 into 1 by factorial 2, because two groups 2 and 2 are same, right? Now we have three groups, means we have make three packets, right? 1, 2, 3. And these three packets we have to distribute in three bags, right? Three different bags. So we know that we can distribute this by factorial 3 ways. We can distribute this by factorial 3 ways, right? So this, add both this thing, you are getting the answer. This is the first method for this. Or we can go by this 5C3 into 2C1 into 2C1 upon factorial 2 into factorial 3, or this we can write 5C2 into 3C2 into 1C1 by factorial 2 into factorial 3. If I have selected 3 balls out of 5, so only like 2, 1, and this is 1C1, right? 5C3, 2C1, only 2 balls are left. So 2C1, then 1C1. Again, 5C2, we have already selected 3 balls. So we have to select now, out of 3, we have to select 2 balls and 1 balls, 2, 2, 1, right? So this is the way, right? First method, you can say by both the way you can go, right? And second, there are 3 bags and the balls are 1, 2, 3, 4, 5. A, B, C. So if you'll see in this case, how many options for ball 1 for 3 bags? So that will be 3. For second again, so this will be 3 to the power 5. For first, we have 3 options, second 3 option, third 3 option, fourth 3 option, 5 3 option. So that will be 3 to the power 5, right? But if I'm writing all the balls are going right 3 ways, so it might be possible the balls are going into 2 bags only, not in the third bag. So now this is for all the cases, the universal case, minus I'm saying key out of these 3 bag, 1 bag is we are removing, right? 1 bag we are removing. So in how many ways we can remove the bag? So that's 3C1. So 3C1, I'm removing this, right? So now we have 2 bags, and in these 2 bags, it will go by 2 to the power 5 ways, right? Plus, now we are removing 2 bags, 3C2, we are removing 2 bags. We have only 1 bag, and ball can go in 1 to the power 5 ways, right? So this again, you are getting the same answer in different ways. This is the inclusion exclusion method, and this is called the distribution method. So one question only you can think in different ways, and might be, and see, first is 3 to the power 5, no restriction is there. Second is I'm saying 3C1, right? 1 bag I'm removing, right? So 2 bags are there, it can go in 2 to the power 5 way. Again, we are removing 2 bags, so it's going with plus minus plus minus plus minus sign, and you'll get the answer for that. That's called the like beauty of inclusion exclusion principle. Please note down everyone carefully. Second method, more specifically we can go with, right? See everyone carefully. Like A, B, C are the three bags. If I'm writing 3 to the power 5, means what we are writing, right? The balls are going in A, B, C, not in A, B, C, not in B and C, not in C, not in going A, B, but C, not in going AC, but B, not in going BC. So these cases are there, right? When we are saying all those cases that contain 3 to the power 5, right? Now 3C1 2 to the power 5. What is the meaning of this? What the cases are coming there? See, 3C1, so I have removed A bag is going on BC, right? Or not A, B and C, or A, B, not in C. This 3C1 2 to the power 5 means it can go in A, it cannot go in A, it cannot go in A and B, it cannot go in A and C. Similarly, this case also contain, if I'm going for not taking B, BA, BCA, right? Or C, AB, CAB, CB, right? So all the 9 cases we are subtracting. So we have to subtract only 6 cases, but by this formula, we are not able to, like we are thinking we have to subtract, right, 6 cases, but ultimately we are subtracting 9 cases. So obviously we have to add all those cases what we have subtracted. So 3C2, 1 to the power 5, that's showing that not going in AB, going in C, not going in AC, going in B, not going in BC, going in A, right? So if I'll add this thing, so you can see only those conditions we are getting, right? Again, subtracting this. So ultimately we are subtracting, this was the case, we have subtracted this case, right? And then add all these cases. So if you'll see, only we will left with the beautiful number ABC only. Means the balls are going into either A, B, and C. And this is called inclusion exclusion principle. This is the beauty of inclusion exclusion, right? Every time you'll get that. So more example we have to do, and for perfection, obviously, we need more question in this part.